Okay, good afternoon, everyone. It's just hit 1:15 now, so we'll get started. And if there's anyone running a bit late, they can join us as we're talking. So first and foremost, before we start today's webinar, I'd just like to acknowledge and pay respects to the traditional owners of the land on which we're meeting, which is Gadigal people of the Eora Nation. So as we're going through the webinar today and sharing our knowledge, teaching, learning and research practices, may we also pay respect to the knowledge embedded forever in Aboriginal custodianship of country. So welcome to today's webinar, and I'll just swap the slide there we go, which is a part of the Quick Bite series, and today we'll be talking about text and data mining. So my name's Ryan Stoker. I'm one of the research data officers here at the University of Sydney Library, and with me today is...
I'm Charles Sun. I'm the data scientist from Faculty of Arts and Social Science.
And we have have Simon and Chris also with us today as well, monitoring the webinar. So a bit of housekeeping before we start. All participants are muted for this webinar, as we'll be recording it and making it available online after the session. If you do have any questions, you're more than welcome to put it into the chat box on the left-hand side of the screen there, and we'll be able to take any questions and be able to answer any questions that you might have at the end of our talk today. So just to give you an overview of what we're covering, we'll give you a bit of a quick introduction onto what text and data mining is and why you would use it in your research. We'll talk about a brief overview of the processes and methods. We won't be able to go through all the methods within half an hour, so we'll be focusing on two, which is sentiment analysis and topic modelling. Then I'll hand over to Chow to talk about sort of the practical examples of that. So we'll show you a few live demos of that. And then some of the tools and resources that are available here at the University of Sydney that you might be interested in using if you are looking at starting your own text and data mining project. So a brief definition on what text and data mining is essentially that it's a use of computational tools and techniques or algorithms to automatically discover new and unexpected information from an aggregated body of machine-readable text. And what we call this is a text corpus, or corpora if we're talking about multiple data sets there. So some of you might be familiar with data mining, which is sort of looking at structured data sets and finding new patterns or trends within it. So the same principles apply there with text, but we're looking at unstructured data there. So, and in this context, we're talking about unstructured in the sense of machine-readable data. So even though something like a text might have a structure, an introduction, body, and that we're able to understand, it's a bit hard for a machine to do so. So that's what we're meaning there by unstructured. So in terms of using text and data mining in your research, a quote that's often shared around is that 80% of the world's data is unstructured. So essentially what text and data mining can help you with is making sense of this large unstructured text, and quite often it's used within providing summary analysis of texts or even single documents as well. So you could be, for instance, looking at a body of journal articles from health or science, and you're wanting to find out, for instance, what those papers are saying, what topics they're covering. And you could read through each of these documents, and it can take you quite a long time to do so. So text and data mining can cut that time and allow you to do that quick overview of that. Or you could have a look at a specific text itself. Quite a lot of people within the digital humanities, for instance, do look at one specific text. It could be, for instance, the works of Shakespeare, and they're able to get a summary analysis of that. The other one that text and data mining can be used is within helping you test hypotheses or looking at trends and patterns to help you answer a research question. So, for instance, it could be what's being said in a set of Hansard or UNHCR reports or grey literature, what are the issues being discussed there, and how are they related to other concepts or other people, or how people are related within a certain event. So it can also help you with discovering those trends and patterns and automating that and making those discoveries, which might not be easy to do just having a read of the text themselves without any machine assistance. So to have an overview of the process, this is just a model that we've sort of come up with just to explain how you'd go about text and data, using text and data mining in your research. And it's sort of similar to what you'd normally do. You'd start off with a research inquiry or a question. You'll go out and you'll collect your text, so either your data or a text corpus, and put that together. You'll probably do some background reading into that and cleaning up and preparing the text into a machine-readable language using pre-processing tools. And then you go about doing your actual analysis, so using or picking a particular method or tool in order to help you answer your research question. This is an iterative process, so you may find that, for instance, when you are doing your analysis, or you might be doing your background reading into your research, you might find particular topics or particular issues coming up, which means that you'll go back and go through the formatting or cleaning again. And you might be going over this a number of times until you actually do your analysis method. Normally, when people are talking about this, they'll normally say that the pre-processing stage, which is the four top stages there, takes up about 80% of this process, and then 20% is actually doing your analysis itself. So there is quite a lot of work involved in the beginning of it, but the last 20% can really help you with answering your research questions, and that's a really fast part there. So it's a bit of a long process to get to that stage, but when you do find how powerful it is, when Chow is showing these examples there, you'll be able to realise that that 8% is worth doing. So I'll hand over to Chow just to explain some of the processes and techniques that are happening, particularly with pre-processing.
Yes, well, for the text mining, first you need to get all your text in certain formats, or you have a large corpus or article. The first thing you need to do is to tokenize that. For English and other Latin language, it's quite easy because there are space between each word. And with different tools, or you can have either individual words or multiple words in continuous sequence. So you can have unigram, bigram, or trigram as you wish. And also another part of this language processing is terming and lemmatization. The red font in the middle of the screen shows how the term works. So the words are referred to their kind of origins of the start, individual. So I'm not a language expert, but this is how the terms looks like. So many words is not a real word after terming. Like occurrence becomes occur, so they are related. And for lemmatizations, they are still words, but the word R becomes B, so that is the lemmatization example. But for language other than English, for example, Chinese or Arabic or Thai, there's no space to divide the word, and different characters can be freely combined, and they are all meaningful. So there are other algorithms to help to segment the words. Here's an example for Chinese, but there are also packages for such word segmentation for different trend for different languages. And once you have your word identified, there are a lot of other stuff you can work. This is one example is name entity recognition and classification, that the algorithm can scan through the article to find the meaning of words. What is whether the word is a people, is a place, or other entities. So these algorithms, for example, the Washington in the first sentence is a person, and the Washington in the next sentence is the location. So this is another area of natural language processing. And for the linguistics, they are more aware of what each word are used in together with other words. And there are algorithms for the tagging the part of speech. So in this example, the highlighted word right has its noun form, its adverb form, or its adjective form. When they are used differently in the sentence, then the algorithm can help you to quickly tag all the words automatically. And on top of this natural language processing procedure, there's also data mining focused algorithm. The one example is the word2vec. Word2vec helps you to map all the individual words into a numeric vector. And the vectors in a space, for example, in the picture, you can see the relationship between man and woman is close to the relationship between king and queen. So if you use king, the vector of king minus vector of queen, it will be similar or close to the vector of man minus vector of woman. And I made a small matrix on the right to show the semantic similarity of the words, of some simple words. And note, the similarities between these words are not exactly how similar they are each other, but it's more about the context of how these words can be used, and they can be alternatively swapped. For example, you can drive a car, and you can also replace the word car with truck. Then they are they're semantically similar to each other. So that's why they have a higher score. And you can walk your dog. Although you normally don't walk your cat, but you can replace that and people still understand. But you definitely can't walk your truck or walk your house. So this is how the word2vec model shows you the closeness of usage in each word. And this model is trained based on the English Wikipedia article. Using different source of corpus, you can train different word2vec models that fit your specific domain.
So going off from what Chow said there in terms of entity recognition and word2vec and other things, you can then apply sort of different algorithmic methods. So as we mentioned, we'll only be focusing on two today, but there are quite a lot of different methods that you can use depending on what your research questions are. So for instance, if you were looking at different entities and how they're related, you could use a thing which is called network analysis. But to go through two of those examples there that you might want to have a look at, a really popular one used in text and data mining is sentiment analysis, which essentially is used to analyze the emotional tone of text. So what an algorithm that looks at sentiment analysis does is that it scores documents based on on effect words to determine the overall tone of a document, whether it's positive or negative in its sentiment. So normally with these algorithms, they'll identify specific words with the tagging that Chow mentioned using training data, which is what's called supervised learning. And it'll classify those, and in the next I've gone a little bit too far there, but in this diagram here, it does give you a sense of what that algorithm is doing there. So in this sentence here, this film doesn't care about cleverness, wit, or any other kind of intelligent humour. It'll identify those keywords such as care, cleverness, kind, intelligent, and humour, and it's assigned that particular score. In this example here, humour's also scored a lot higher in relation to other words like kind and intelligent. Also with this scoring, it also identifies negation. So the word doesn't is an indication there to the algorithm that that particular, that the rest of the sentence will have a negative tone. So even though the last part of the sentence is overall positive, it is negated by the word doesn't, and then the algorithm makes a determination there that the overall sentence is negative. You can scale this up to a larger document using average sentiment, which is essentially an algorithm will score each sentence and assign it a score, added up by the number of sentences present in the document, and then divided by that number of sentences, which then will give it a score, whether it's positive or negative. And you can use that to see in relation to other documents in a corpus where that sits in terms of its emotional tone. It's often used quite a lot in social media and particularly Twitter to see or to gauge basically how people are reacting to certain topics or what those tones are. And Chao will show you an example of that.
Here's an example of I'm sharing the screen with you. So this is a work we tried on Twitter data. This is because the sentiments are in Twitter data need to have a target, like you have a negative attitude to some topic. So we select two topics from a China state media's post, and we only selected the replies or comments to these posts. So it could be a news, it could be a video, and people start to comment on these original tweets. And we select one topic is panda, and another topic is one bear, one road. And on this map, it plots where the commenters are, and the red color indicates a negative attitude, a sentiment, and the green can be a praise. So this is for panda, and that's different distribution of bear and road. So in order to get the locations, we actually use the automatic geodecoding service, which is automatically done. And for the sentiment, there's existing package trained on the movie reviews. So here's a negative one. We can see there are some fake and crushing weak people, etc. So that's a negative view of reviews on comments on the Bear and Road. And this is gray, so that's simply a positive. But the sentiment analysis is based on the words you use. So although there are some algorithms there, but still it's not very reliable, especially when there's sarcastic or not very straightforward message, then it can make a mistake. So in this work, based on our experience, we did a test on small data set. The intercoder reliability means that between the machine and human being, about 70%. So that means about 70% of our decision agree to each other. And that means you can't trust it overall. You just get a big view on how the sentiment appears to be in a large scale.
And the other method that we'd like to show you today is topic modeling. Topic modeling is one of the other most common methods in text and data mining for analysis. And essentially what this is the algorithm will pick up frequent co-occurring words within a corpus, and it'll sort them into different topics based on what's called bag of words method. So basically what happens here is the algorithm will break down sentences into their individual words and count the number of times a word will appear in a text. And basically it'll go through the first document, have a look at the frequency of words here. So in this example here, the author published a novel. It'll pick up, for instance, the words published and novel, see that they appear quite frequently, and it'll put it into one topic. It'll go through the next document and do that same process again. So in the second document that it's found published and novel also appears frequently, and it'll group those together in one topic. Again, it'll have a look through the other documents in the corpora. So this one here is picked up with documents saying artist and exhibition frequently, and the algorithm determines that that's another topic there, and it'll put it into that grouping as well. So it's sort of a bit like a reverse search in a sense, where instead of yourself putting in the keywords that you're looking for, you are asking the algorithm to have a look at your documents and be able to determine what topics do come out of that. And Xiao will show you an example of that. But to explain that bag of words limitation there, it's sort of a basic score, really, in terms of the frequency of words. And
so here's an example. We worked with a historian who's interested in human rights in the history, and we selected the UK parliamentary debates, the Hansard dataset, to show, this figure shows the topics, 35 topics identified between 2000 and 2005. And as you can see, each small bubble is a collection of words that often occur together in the debates. And this is about children, religious parents, and school, church, etc., and also marriage. And if you select another bubble, it's a different topic, although the computer don't really understand the meaning of words. It's all based on statistics, how often these words are used together. And some of these topics makes good sense, but some other topics doesn't make much sense because, there are also common words also always happen together. So it's need to be interpreted by the human being, a domain expert, to find out whether a topic is something they think about. It's basically a cluster of words. So the researcher can actually use this topic modeling to go through large set of data or text. Can we go back? Yep. So this is also often referred as distant reading. So you don't have to read every single article, but you can get a general knowledge on what these debates or articles are about when you use this algorithm, topic modeling, to go through it. And you can use different parameters to go through to have a good understanding on what is mainly discussed in these corpus. And also the topics can be considered as components of article. We might find, a document has 30% of topic 1, 5% of topic 2, and 45% of topic 6, etc. So that can be considered as different topics construct the document. And if you find another document with similar distributions on the topics, then it's one way to determine whether two documents are similar to each other, or are they talking about the same issue or in a close region. So in one of our recent work, we combined the word-to-vec topic modeling and another distance metric called Earth mover distance to find out the similarities between different topics. And then in hierarchy, we identify the similarity between articles and their authors, which are the researchers. Then in this way, we measure the similarity of researchers based on their previous publications. So one point here is, although there are many different algorithms and methodologies, based on your own research aim and question, you can freely combine and use different technology together for your particular question.
So to wrap up with our talk today, I'd also like to talk about some of the resources that you can use if you are sort of interested in testing out yourself around text and data mining or wanting to start a project on it. The first thing that we do have is we do have a guide on finding resources and a bit of an overview on the text and data mining process on the University Library's website. So I'll go back into our screen share again, and I'll just show you how to navigate to that. So when you go to the library's website, you'll reach the home page. Simply click on the research bar at the top, then go to Manage Information and Data, and then there's a link here to text and data mining. So that'll take you to the page, and what on this guide, on the guide here essentially, is that it'll give you a bit of an overview of the different tools that you can use, such as Mallet and Weaker. Also, some of the programming languages. Quite a lot of text and data mining is done in R and Python. But also some issues to consider that we'll talk about briefly. But also a list of publicly available resources that you can use. So, for instance, Biometric Central, bomb data feeds, government data, Facebook, the Haiti Trust, which is another good resource there. And there's also information about some of the licensed resources that are available too. So you'll be quite surprised about the sort of range of databases that do offer text and data mining, particularly scholarly journals or primary resources. So Gale, JSTOR and ProQuest are really big proponents of text and data mining. So you can definitely have a look through the list here to see what licenses are available and what sources of material that you can use for text and data for your own text and data mining projects there. Just to talk about some of the sort of things to consider when you are doing text and data mining, particularly when you are sourcing resources, is first and foremost, sort of our recommendations are to check the library website to see if we hold the rights to mine your chosen data source, or if it's something that's not listed on our website, having a look on the terms of use or license agreements on the data provider's website to see if you can text mine. You should also be aware of the methods or ways that you can access the data. So whether or not the database providers ask you to go through what's called an advanced programming interface or an API. Some other providers, such as ProQuest, do prefer to mail out a hard drive with the data on there. One thing with text and data mining, particularly when you are sourcing material or data for it, is that it is quite a intensive process on the database provider's end. So it's a bit more of a adequate. And likewise as well with that, complying with the requirements or preferences with the data provider when you are looking at mining your data, mining a data provider's source. So again, having a look at the arrangements and also contacting the data provider sometimes just to make sure that they are fine with you trawling through the website to get your data sources. So mentioning some of the tools and resources, there is a wide availability of different resources that you can use. Again, we could spend a whole hour talking about the different tools you can use, but I'll just talk briefly about two. The first one is Voyant Tools, which is an online open source tool that you can use. The web link's just on the bottom there. With this, you can use it to have a look at topic clustering that Chow mentioned, either through available websites, so you can put in a web URL, as you can see there in that diagram, but you can also paste full text or also upload your own documents. And it'll give you an overview of the topics that appear in the different documents and other different tools which you can use to analyse the topics and see frequently occurring words and other methods there. There are a lot of resources available online on how to use Voyant as well, either on Voyant's website or tutorials that are available as well. So it is quite a popular tool there. The other one that you might be interested in having a look at, and they do produce a number of textbooks as well, is the Open Data Science Toolkit. So you can download this as a sort of self-contained virtual server, which you can use for a number of different tools there. So, for instance, They do have tools for sentiment analysis and topic modelling, but as you can also see there in that diagram, you can also look at coordinates or street addresses based on the text that are available. So picking out different locations. They do have a wide variety of different little tools and resources that you can use there. They also provide some really good guides in terms of explaining the different methods and how to use them and in what ways that you and sort of the processes to go through that as well. So I do recommend that you go to datasciencetoolkit.org. They have their resources freely available as well, which are quite useful for you to use. So this really wraps up today's talk. This is just a list of references that we've used in today's talk. A lot of the two that I might mention there as well, particularly with entity recognition and topic modelling or latent decorative allocation. Those two top references there are really good in terms of explaining it in a bit more detail if you are looking at wanting to find out a bit more about the technical, the underlying technical explanations in terms of those two tools there. But otherwise, does anyone have any questions, or did you have any final comments to say, Chow, around that?
Well, if you are a member of University of Sydney, we also have local support for data science. We have a Center for Translational Data Science if you have research collaboration needs. And also there is a core research facility, Sydney Informatics Hub, will help you to provide service on data science. So, and also if you are from Faculty of Arts and Social Science, you can contact me directly. We can have a talk on your needs and your research questions. And
we'll be more than happy to send through a list of emails in a wrap-up email as well, if you're interested in getting in touch with the Sydney Informatics Hub or Chow. Likewise, we can also, definitely if you are having got any questions around finding appropriate sources for text and data mining, you can contact my team as well, the Research Data Support team. We can help you with finding those resources, or even just sort of talking about your project as well and what you're looking for. But of course, if you do have any questions, feel free to get in touch with us.
So for joining.
Yes, thanks very much for joining us.